So what we're going to do now in this part is we're going to look at the next section on the test, which is verifying. And we have these two problems to complete. So follow along. Alright, in this problem, which is problem number 8. Oh, sorry about that. Okay, problem number 8. We have to prove that this side is equal to cosine squared x. So we're going to work on this side only. And the first thing you need to realize is that this is equal to something. And I'm going to show you now on the identity sheet. You see right here, cosecant squared x minus 1 equals cotangent squared x. Alright, so we're going to replace this with cotangent squared x. And this is still over the cosecant squared x. Right? And we're just going to go ahead and bring this down. And we're never really going to touch this side. What we're trying to do is get this side to equal this side. Alright, well, we've definitely simplified it, but one of the things that we can still do is we can still turn this into sines and cosines. You know what cotangent is. Cotangent is cosine over sine. And cosecant is 1 over sine, but they're both squared. So watch. That's your numerator, that's the denominator. Here we go. The numerator is going to become cosine squared x over sine squared x. They're both squared because the cotangent squared. And the denominator, the cosecant, is going to become 1 over sine squared x. Okay. And this one's squared because the cosecant is squared. Right, so you see that? And this is still equal to cosine squared x. Alright, we're just bringing this down. What we're going to do now is we're going to keep the numerator, change to multiplication, and we're going to flip the denominator. So watch. We're keeping the numerator. What's the numerator? This whole thing. Alright, so we have cosine squared x over sine squared x. Instead of dividing, we're going to multiply. And we're going to flip the denominator. What's the flip of this? This is already 1 over sine squared x, so the flip is going to be sine squared x over 1. And we're trying to get this to equal cosine squared x. Now what you notice about this side is now it's multiplication. Now we can cancel. These cancel. And you're left with cosine squared x over 1. And cosine squared x over 1 is cosine squared x. We have proven that the original problem is equal to cosine squared x. Done. Alright, this is problem number 9. And what we need to do is we need to prove that all of this is equal to cosecant x. Alright, and what we need to realize is that this negative sign separates these terms and these terms. So these are all together. This is multiplication. And these are together, that's multiplication, right? And do we have anything in common? Yes, we do. We have the secant in common, and we have at least one cotangent in common. Alright, we can take out a cotangent, and we can leave behind 2 cotangents over here. So let's go ahead and do this. Alright, so we're going to take out 1 cotangent x and 1 secant x. So this will be gone and that'll be gone. So what's left over? Cosecant squared x minus. If we take out a cotangent from here, we'll have 2 cotangents left over. And when we take out the secant, nothing is left over, right? Or basically a 1 is left over. A 1 is left over in their places, which we just multiply. Alright, so this is still equal to cosecant x. Ready, ready, ready? Here we go. Let's change everything into sines and cosines. Cotangent is cosine x over sine x. And we're going to multiply this to 1 over cosine x because that's what the secant is. Alright, inside the parentheses. Remember, inside the parentheses, it's its own world. Okay? Cosecant is 1 over sine squared x minus cotangent is cosine squared x over sine squared x. And look, we have a common denominator, so we can combine this. And over here on the outside, the cosines cancel. So we have 1 over sine x, 1 minus cosine squared x over the sine squared x is still equal to the cosecant x. Okay? And if you've been paying attention, you know what this equals. And if you don't, stop the video right now and go look in your identities. 1 minus cosine squared x is sine squared x. So 1 over sine x. This is sine squared x, the numerator, over sine squared x equals, and we just bring this down, cosecant x. And look at what happens here. They cancel. So it becomes a 1, right? So you have 1 over sine x equals cosecant x. And yes, 1 over sine x is cosecant x. And cosecant x equals cosecant x. There you go. We have proved it.